The system shown in figure P5.43 is used to lift an object of mass 76 kg. A constant downward force of magnitude F is applied to the loose end of the rope such that the hanging object upward at a constant speed. Neglecting the masses of the rope and pulleys, find A, the required value of F, the tension T1, T2, and T3, and C, the work done by the applied force in raising the object a distance of 1.80. Okay, so let's draw all the forces that works on this system here, and I will use this mass here as our reference, and obviously we have the weight of it, right? So I will have weight, and then in the upward direction I will have this T2, and we can apply Newton's second law on this system here. So I will have sigma F is equal to the mass times acceleration. Remember that it's moving in the constant speed, so I will have the right hand side here is equal to 0. Constant speed meaning that no acceleration, right? So this was the acceleration is 0. Okay, so the positive one here is T2. Okay, and then the negative one here is weight. So I have T2 minus W. So I will have this equal to 0, or T2 is equal to the weight of this block. Or the weight of that block, that will be the mass times gravity. But then the mass is 76. So I have 76 and then multiplied by 9.8. Okay, plug that into calculator and we will get 76 times 9.8. That will be 744.8. 744.8, and the unit here will be in Newton. Okay, so this is one of the parameter that is asked by the question, right? T2. Okay, now let's move our reference point here in this pulley here. So here the direction of T2 will be pulling this down, right? So I have T2 here. Good. And here we have the force of F here pushing this down, right? So that is F, but then that F will be transferred into this rope here, right? And the direction will be changed. So this one is going upward like this, and that is, we name that T3. However, this is still the same rope, right? So I will have F is equal to T3. Good. And also it is still the same rope here, but then this one is named T1. So I will have T1 going there, but it is still the same force. So I will have F is equal to T3 and also equals to T1. Good. Now let's draw all the forces that is works on this reference point, right? I will use here, this one here as our reference. Okay, and then the one that is pushing it down, that will be its T2, right? So I'll have T2 pushing this down. And then we also have T1 here pushing this up, T1. And also we have T3, right? We also have T3 pushing that up like this. Good. And again, we can apply the Newton's second law. We will have sigma F is equal to the mass times acceleration. And remember, it is moving in the constant speed. So the acceleration will equal to 0. And the positive one is T1 and T3. So I have T1 plus T3 here. And that will equal to, minus T2. Minus T2. And that will equal to 0. Because we know T2, let's move it to the right hand side here. So I'll have T1 plus T3 is equal to T2. And then we'll have T1. Here we have T3, but T3 is equal to T1 here. So I will have T1 here And T2 here is 744.8. So I will have 2T1 is equal to 744.8, or T1 here is, we can divide both sides by 2, right? So we will have 744.8 divided by 2. Okay, so I will have 372.4. 372.4. And the unit here will be in Newton. And that is T1 here. And that is also one of the variables that is asked by the question. However, we also have T3, right? T1 and T3 is the same. So I will have T3 here is 372.4 Newton. So that is T3. Good. We have answered all the question B. Now we can also answer question A here. We need to find out this F, right? But F is equal to T3 and T1. And we know the value of T3 and T1, which is 372.4 Newton. Good. And then for question C, okay, we have answered question A here. The work done by the force raising the object at a distance 1.80 Newton. So let's answer question C. The work is the force multiplied by the distance. What is the force? So I have 372.4 multiplied by 1.8. And that will equal to, just plug this into calculator, right? So we will have 372.4 multiplied by 1.8. And that has to be 670, okay, 670.32. And the unit here will be in joule. And that is the answer for question C. We answered the work done by the applied force. So we have answered all the question here. So this 3 is for question B. I think that's all for this problem. Hopefully I did not make any mistakes during my calculation. Thank you for watching and see you in the next video. Bye bye.